Already we have seen the Schrödinger and Heisenberg fixture. Now we will see the interaction fixture or Dirac fixture. This is formulated by Dirac. In the interaction fixture, both operator and quantum states carry the time dependent. In the case of Schrödinger picture, only the wave function or wave vector has time dependence. In the Heisenberg, the operator is time dependent and wave vector are time independent. In this case, both are time dependent. So the Hamiltonian h of t can be separated into two parts. One is time independent, which we are labeling as h naught. The other one is time dependent, which we are labeling as h prime of t. Now, uh, Dirac formulated that wave vector in interaction picture, that is get psi I of t is equal to e power plus I h naught t over h cross psi gets psi s of t. Why he used the Schrödinger wave vector is, in Schrödinger wave vector only the wave vector is time dependent. In the Heisenberg picture it is time dependent. So that is the reason why he used Schrödinger wave vector. And here note that it is not a time evolution operator. This is complex conjugate of the time evolution operator. So he formulated like this. From this, we can identify the wave vector in Schrödinger picture at time t is equal to, you bring this to the other side, will become e power minus I h naught t over h cross. This is the time evolution operator. And note that when h prime of t equal to 0, the Heisenberg picture and the Schrödinger pictures are the same, because when this is 0, the time factor will go away. Only this is time independent. Hamiltonian is time independent. That is h of t is equal to h naught. So the interaction picture and Schrödinger pictures are same if this time dependent Hamiltonian is 0. So then we will move on this. You remember this expression, then we will move on the interaction picture. Just now we have seen that get psi I of t is equal to e power I h naught t over h cross get psi s of t. So from this we have also seen the get psi s of t can be written as, if you bring this exponential term to the other side, this will become e power minus I h naught t over h cross get psi I t. Now you take the time derivative of this wave vector. If you take time derivative, what will happen? First, you take this exponential term, time derivative of exponential term. You will get h cross, I over h cross h with that exponential term, e power plus I h h naught t over h cross. So you will get this. Here, since h will commute this exponential h naught here, sorry, here it is h naught. You can change it back and forth. So I have brought this h naught in front of this wave vector. Then I h cross will become minus 1 over I h cross. That is, if you multiply and divide by I, numerator and denominator, you will get I h cross. So I into I is minus 1. So minus 1 over I h cross, this exponential term, and h naught, because you have this, when you differentiate it, you are getting h naught. H naught act on this wave vector psi s of t. Then next, you differentiate this get vector. If you differentiate the get vector, what will happen? You know very well that IH cross T psi over TT is equal to H psi, or T psi over TT is equal to 1 over IH cross H psi. So I am replacing this by H psi. Of course, 1 over H cross. Now you can understand why I brought this into this form. Now, next what I am going to do is, I am going to replace, sorry, here it is H naught. So, here it is, sorry, H only. Sorry, here it is H only. So, then what we are going to do is, let us take, replace this psi of s. Here you have one psi of s. Here one psi sub s. You replace this by this one. So I am replacing that by exponential time evolution operator, which act on the wave vector in interaction picture. Same thing here. Why I am doing is I want to bring all in terms of wave vector in interaction picture. So I used this relation, so and I replaced that is time evolution operator act on interaction wave vector in interaction picture gives you the wave vector in Schrodinger picture. So now we will further simplify this. Now we got this expression. Uh, See that here in both term you have IH cross and here one IH cross in the denominator. You bring to the left hand side, it will become IH cross this time derivative. Then you can see uh, this H naught. You have exponential term, same exponential term for H naught and H. So you can take this exponential term plus e power I H naught t over H cross and e power minus I H naught t over H cross. Now I am taking as usual positive term first. This is plus and this is minus H naught. So this is exponential term, that is this is u dagger h naught u, that get vector psi I of t. So now we have seen at the beginning that the Hamiltonian can be separated into two parts. H of t equal to h naught plus h prime. H prime of t. Here what is, if you bring h naught to the left hand side, what will happen? H minus H naught is equal to H prime t, which is a function of t. So I am replacing this by H prime. This negative sign, of course, I explained, I brought inside. So H minus H naught. We will try to simplify it further. So we got that IH cross the times the time derivative of get vector in interaction picture is equal to this one. Here this can be taken as HI prime. I have replaced that as a HI prime, which depends on the time, and of course this get vector psi I of t. This is the Schrodinger equation in interaction picture. It is identical to Schrodinger equation in the this is identical to Schrodinger equation, but it is in the interaction picture. Instead of H, we got Hi prime. So only that is different. It shows that time evolution of a state vector is governed by interaction Hi prime. Time evolution means, it is clear. We are taking time derivative. It is nothing but time evolution. Time evolution is governed by this Hi prime. So This is about the interaction picture. We will see the time derivative of the interaction picture. We will see the time derivative of the operator in interaction picture. So the operator in interaction picture, which is a function of t, is formulated by Dirac as e power I h naught t. Remember that it is h naught divided by h cross. The operator in Schrodinger picture, e power minus I h naught t over h cross. Remember that here the operator in Schrodinger picture is time independent. Time factor is taken care of this exponential term, that is time evolution operator and complex conjugate of time evolution operator. If you take the time derivative of this operator as done in the case of Heisenberg, which I am not uh, going to derive it here. You can take it from Heisenberg. Same method, you adopt the same method, then you will get 1 over I h cross commutation of A of t with h naught. Of course, there is a time derivative will come into the picture, partial time derivative of the operator, if there is a explicit time dependence of AI. So this is the time derivative of the operator in interaction picture. Thank you very much for watching my video and supporting me continuously. Thank you very much.